Hello guys, in last video we saw the linear search. We saw how inefficient it is to search a very big number in a very big array. Suppose you have a million of numbers in an array and you want to search a number which is close to million, then it will take around a million of steps to search that number in linear search. So it is very inefficient because you do not have that much of memory power or that much of even time to spend on an array of size 1 million, and that too if the array is sorted. So here what we are going to see is a very good algorithm known as binary search. Whenever you get an array which is sorted either in ascending or descending order, you are getting some extra information which you can use to search any element in that array in very less number of steps. That's exactly what we are going to see here. So in the game that you saw in the video, there were two players. One was Ravi and Amit. They were playing a game. So Ravi has an idea that he can guess the number which Amit has thought in a very less amount of iterations. So the game is like this. You guess a number between, let's say, 1 to 1000, and then the second person first computes the midpoint of that array. So in 1 to 1000 the midpoint is 500. Then he asks whether the number that you have guessed is equal to 500 or not. If it is 500, then okay, I got the number. If it is not 500, then he asks whether it is less than 500 or it is greater than 500. So suppose the number you have guessed is less than 500, then you can see that you can safely discard the other 500 elements in the array, because your number will never go beyond 500. You have already said it is less than 500 and the numbers are sorted. So you can never go, you do not have to search the other part of the array. So you can safely discard the numbers from 500 to 1000. So number of elements that you have left now is 1 to 500. Then again I will compute the midpoint of this array which is left to me, that is 1 to 500, which is the midpoint is 250. Then I will ask you again whether your number is 250. If you says yes, then okay. If you says no, then again I will ask whether it is less than 250 or more than 250. If it is more than 250, then again same logic I will use. Since it is more than 250, I do not have to search it less than 250, because it will never happen that the element will present in the array between 1 to 250. So I can safely discard the numbers from 1 to 250. Now the array which I have left is 250 to 500. Again I will ask the same question, that is I will compute that midpoint of 250 to 500, and I will use that midpoint to ask the question and go to the left part of the array and right part of the array. This is the logic of binary search. In this, at each iteration, whenever you are computing the midpoint, you are discarding the half part of the array. This way your size of the array is reducing by 2 at each iteration. So we'll exactly use this logic to do the binary search. So let me write the definition of binary search. Def binary search. It will take two arguments. One is the array, let's say my array name is A, and the other is the element that I want to search. Great. Now I will create two variables. I will use these variables to position my array. I want to know, I will create a variable, let's say first pose, which is 0, because the array starts with 0, so I can safely take 0 as my first position. And the last pose, which is the last position of the array. Python has a function named as len, through which you can compute the length of an array. So suppose if I type len of I will get the length of array. Now it gives length of array gives the number of elements in the array, but we know that list or array, whatever you say, in Python starts with 0, so you have to take -1. So let me try this in console. Suppose my array name is array1 and the elements are 1, 2, 3, 4, 5. Okay. Now if you type length of array1, you'll get how there are 5 elements, so you'll get 5. But the position of fifth element is what? Is actually 4, because the array starts with 0, 0, 1, 2, 3, 4. So suppose you want to retrieve the last element, you will type array1, and if you type 4 here, you will get the fifth element. Or you can type array length of this array1. Okay, this length of array1 will return the number of elements in array1, which is 5. So number of elements in array1 is 5. If I put -1 here, so this whole thing means it is 5, which is returned by the length of array1 -1, which is 4. So this will give me the fourth element, which is 5. So this is exactly what we are going to do here. So I will put the last position as length of array -1. Okay. Also I will take a flag value which I will use to see whether I found my element or not. Okay. This warning means that all these variables you have created these variables, but you are not using it. So as soon as I use it, all these warnings will go. Okay. Now I will create a loop, while loop. Let's see how to do this. And let me write this first, and then I will explain it, what exactly I'm trying to do. So I will type first pose is less than last pose, and flag is equal to 0. What does this mean? That keep this loop going on until the first position is less than last position, which is these two variables. If first position is always less than last position and flag is equal to 0, I told you flag, you can, let me write a comment here. Flag means that flag equal to 0 means that the element has not been found yet. So it means that you should continue the loop until first position is less than last position and you haven't found the element you are looking for. Till then you have to continue this loop. Okay. So what I will do, first, what was the strategy? So I will first compute the midpoint of the array. So I will compute mid is equal to, right? So I can compute in order to compute the midpoint of an array, I will take the first element, the position of first element, the first position of the array, the last position of array, I will add it and divide it by 2. This way iteratively I can compute the midpoint of any subarray. So I will write first pose plus last pose divided by 2. Now if I write divide by 2, it will return me a float value. You can check here. Suppose if I do 5 plus 2 divided by 2, it is giving me 3.5. But I exactly want an integer value. So suppose the number is odd, it should give me the integer value either left or right. I don't care much, but it should give me an integer position, because it is a position. If I use this float value, then I will not be able to retrieve the element at that position. So I need an integer value. So for that I will do the there is a called as integer division in Python. That is, I will write 5 plus 2 to this division, and it will give me 3. This is what I want, so I will put this one more division operator here, and I'm done. So I computed the mid. Now what I will check? I will check whether this element x is present in mid or not. I will write if x is equal to a of, because mid is my position, mid. If it is there, then I'm done. I don't have to check for another thing. So I will write, I will make the flag is equal to 1. It means I found the element, and I will write print the element present at position. I can write the, I can give the position of this mid variable, which is, let me write str mid. You can add +1 also, so that you can get the exact position, but I'm not writing it because I'm assuming that you all know that array starts with 0. So I'm, in that context, I'm just printing the mid value. So that's it. You can return from here. It means that whenever you found the, whenever you get the element which you are looking for, you can just return it. You do not have to do other computations. I will just return from this return will return the function value, which I'm not returning anything. It means it will get out from the function to the main where I'm calling the function. That's it. Okay. Now, if it is not present at the mid position, then I have to check whether it is on the left side or on the right side. So for that, I will write else if it is not present at the mid position. If this x is less than array of mid, which means if x is less than mid, I can discard the right side of the array, which means what? I can safely write that last position is shifted to what? Mid -1, because mid and after mid I can discard, because mid is, in the first question, in the first condition, I have checked whether it is present at mid or not. If it is not present at mid, then I can discard the mid and all the elements after the mid. So I will safely make I will reduce the size of my array by positioning the last position to mid -1. This is why I'm discarding the other elements of the array. Or if it is not, if it is not less than the mid, it is more than the mid, then I can discard the first part of the array, which is from 0 to mid. I can discard. For that, I will just shift my first position as first pose is equal to mid +1. That's it. Okay, I'm done. My program is over. And if the function doesn't return anything after all these things, it means the array, I didn't find the value which I am looking for. So I can safely print here after this loop. It means that loop is over, but still I didn't find the element. I will write the number is not present. That's it. Now, in last function, the linear search, we were printing the number of iterations also, how many iterations it takes. So here also I would like to print the number of iteration it is taking to find this value x. So I will create a count variable, count, assign it to 0, and at every iteration of while loop, I will increase the value. Now here I have printed the element where it is present, I will just print that the number of iterations are, which is string of count. Okay, cool. I just need to call this function. So in order to call this function, here I will create an array. So let's say my array name is A, and I will enter the elements in this array for I in range 1 to 500, let's say. A dot append I, and I will call this function, which is binary search, and I have to give the a, and let's say the number I want to search is 70. So our program is complete. So I will just run this program to see the output. Okay, now it is showing the number is not present, and I exactly did what the logic was present for the binary search, and I know that number is there. Suppose if I type A, you can see that 70, which I am looking for, is present, but still it is showing the element is not present. Let me try this for a small number. Let's say number of elements are 10, and what I want to search is 4. Let me try this. Still it is showing that number is not present. Let me see the numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 4 is there. Now what is exactly happening is that whenever the condition that I put here, while first position is less than last position, it might happen that sometime the first position and last position will be the one number. Let's say first position and last position are pointing at 4. At that time, still we have to have one iteration search is required, but this condition will fail. That is, first position is less than last position. It is showing that here the first position is not less than last position, it is equal to last position, and here it will fail, and I will not be able to search this element. So to do this, I have to make this condition as less than equal to, which means when first position is less than equal to last position, until then you have to search for the element. Now you can see if I run this, it will show that number is present as position 3, which is 0, 1, 2, 3, and the number of iterations is 4, because 4 times I have to switch to this. Now let's see this. Number of elements will be 101, and I will search for number 70. I'll just run this. See, the number is present at position 69, 70. Now in linear search, what we were looking for, we search for a number, the number of elements we put were 1000. Okay, and we were searching for the number 1000, and it was taking 1000 of iteration. Now here, let's see how many iterations it takes. I will run this. See, the number is present as position 999, and in 10 iterations I was able to search this number in just 10 iteration, where it was taking 1000 iteration in linear search. It takes just 10 iteration in binary search. Suppose I make this 1 million, let's say. Okay, and I want to search this number. Let's say 1 lakh. Okay, see how many iterations it will take. In just 20 iterations, I was able to find the number. Whether, as you all know, to find this number, it would have taken 1 lakh iteration in linear search. So this is the beauty of binary search. You can do, actually it takes exactly log of the number of elements in the array. That is, if the number of elements are, let's say 16, then it will take 4 iteration, 32, then 5 iterations, and so on, 64, then 6 iterations, like this. Because every time you're dividing by 2 and discarding the rest, other part, you're taking only one part at a time. This way, half of the array is every time discarded, and you are reducing your space by 2, exactly by 2. Every time by 2, by 2, by 2, it becomes log of 2, log of base 2. So yeah, we are finished with the binary search. Please, if you have any questions, please post it on discussion forum, or you can, if you think you can, this is a very simple program. If you think you can create a more efficient, more elegant program like this, better than this, please post it on discussion forum. It might help other people to learn. Okay guys, thank you.